So in this video, we're going to be looking at page 8 of your packets, and we're going to be talking about multiplying radicals. And we have a couple of steps here that we'll just refer to back at the end. But I'm just going to dive on in with this first example and show you guys that if we have a 3 times the square root of 2 times a 4 times the square root of 5, we have the 3 times the 4 that we're going to multiply. And then the square root of 2 times the square root of 5, we're actually going to multiply that as well. Now, it might not make sense to you why the square root of 2 times the square root of 5 would actually multiply to be the square root of 10. And I'm going to show you guys with a couple of examples here. If I take the square root of 9 and multiply it by the square root of 9. Well, the square root of 9 is 3. The square root of this 9 is 3. And if I now multiply these numbers, I get 9. So the square root of 9 times the square root of 9 is the same as this 9 times 9, which is 81. And now I take the square root of it, and that's the 9 that I get right here. Okay? So it works that we can multiply the 9 and the 9 together and make it the 81, and now take the square root of that answer. Let me give you guys another example. If I take the square root of 25 and I multiply it by the square root of 4. Well, you know the square root of 25 is 5. And you know the square root of 4 is 2. So when we multiply these together, we get a 10. Or we could have multiplied 25 times 4 to get 100. And now what's the square root of 100? It's 10. So when multiplying a radicand, which is the 25, by another radicand, which is the 4, you can just multiply them together, and that's the new radicand, and now you can take the square root of that value. So back to our example here, the 3 times the 4 is going to be the 12 that's on the outside of the radical, and then the square root of 2 times the square root of 5, 2 times 5 is 10, and 10 is simplified. There are no perfect square factors of 10, so this is the final answer. Now for the next one, we've got the 9 times the 5 is 45, and now we've got the 2 times the 6 is 12. Now 12 actually can be simplified because it is the product of 4 times 3, and we know the square root of 4 is actually 2, so we can take that out. So now we've got the 45 on the outside times this 2 is where I get my 90, and then this 3 stays right on the inside. Now for the 12, some of you might still prefer your factor tree. That's totally fine. You've got a 2 times a 6, and then you've got 2 times 3. And so then right here is the 2 that we take out, which I have here in red. And then the 3 is what would stay inside. Friendly reminder that there's a 45 out here because 9 times 5 is the 45, and 45 times 2 is now the 90. And 90 times the square root of 3 is our final answer. Now for this one, we have the 4 times the negative 8 is negative 32, and that times this 2 is the negative 64 that I have on the outside. Now here I have a 3 times a 15 times a 2, so 3 times 15 is 45, times 2 is 90, and that's the radicand right here. So the red number is the negative 64 from the numbers on the outside, and the blue number is the radicand from the 3 times 15 times 2. Now once again with 90, we can simplify that. It does have a perfect square factor of 9, and the square root of 9 is 3, so that's now out here with the negative 64 to multiply to become negative 192. Now inside we have left the 10, and since that's just a 2 times 5, there's no pairs to circle out there, so we are done here. Now again, with that 90, you might choose to do a factor tree that is fair. You have your 2 times 45, which is 3 times 15, which is 3 times 5. So when you're looking for your pairs, we have a pair that we're pulling out. There's the 3 that I pulled out here in green, and then the 2 times the 5 is 10, and that's what stays underneath the radical. So this little video, what I've done is I've showed you that you multiply the numbers on the outside, then you multiply the numbers on the inside of the radical, and then you have to check to see if we can simplify that radicand. In the first problem, when we multiply the 2 times the 5, our radicand is already simplified. In the second problem, when we multiply 2 times 6, we have to simplify this radicand further. And in the last one, the 3 times 15 times 2 gives us 90, and we simplified that radicand further. Now you are going to finish the rest of the page for practice, and you'll just check a key when you are done. Thank you.